more than 4.5 billion years ago, long before Earth had oceans, before mountains rose, before even the idea of life existed. Our solar system was nothing more than a vast, swirling cloud of gas and dust drifting through the darkness of space. This enormous cloud, cold, diffuse, and seemingly lifeless, held within the ingredients of worlds yet to be born. And from that ancient chaos, Mars would eventually emerge. The story of Mars begins approximately 4.6 billion years ago, when a region of this massive molecular cloud began to collapse under its own gravity. Something, perhaps a nearby supernova explosion, triggered this collapse, compressing the cloud inward. As gravity pulled material closer together, the cloud began to spin faster, flattening into a rotating disk. At the center of this spinning disk, pressure and temperature increased dramatically until nuclear fusion ignited. Our sun was born, but the sun was only the beginning. Surrounding this newborn star was a wide disk of leftover gas and dust, the protoplanetary disk. Within this disk, microscopic grains of dust began colliding. At first, they stuck together through static electricity. Tiny particles became pebbles. Pebbles became rocks. Rocks collided and merged into kilometer-sized bodies known as planetesimals. And as these objects grew larger, their gravity strengthened, pulling in even more material. This process is known as accretion, the gradual growth of planetary bodies through repeated collisions and gravitational attraction. Over time, certain regions of the disk accumulated more material than others. Closer to the sun, temperatures were too high for gases to condense, so only heavier, rocky material survived. It was in this inner region that the terrestrial planets formed: Mercury, Venus, Earth, and Mars. Mars formed relatively quickly compared to Earth. Isotopic studies of Martian meteorites, pieces of Mars that were blasted into space by impacts and eventually landed on Earth, reveal that Mars likely completed most of its formation within the first 2 to 4 million years of the solar system's existence. In cosmic terms, that is astonishingly fast. Earth, by contrast, continued growing for tens of millions of years. Because Mars formed so quickly, it is often described as a planetary embryo, a world that began forming early but never fully matured into a larger planet like Earth. Scientists believe this stunted growth may have been influenced by Jupiter, the giant planet forming farther out. As Jupiter grew, its immense gravity disrupted the distribution of material in the disk, scattering debris and preventing Mars from accumulating enough mass to become larger. As a result, Mars today has only about half the diameter of Earth and just over 1/10 of Earth's mass. During its formation, Mars endured intense bombardment. Massive planetesimals and protoplanets collided with its surface repeatedly. Each impact released enormous energy, heating the young planet until much of it became molten. For a time, Mars likely possessed a global magma ocean, a world of flowing rock and blazing heat. As the molten interior churned, heavier elements such as iron and nickel sank toward the center under gravity, forming a dense metallic core. Lighter silicate materials rose upward, creating the mantle and crust. This process, called planetary differentiation, gave Mars its internal layered structure: core, mantle, and crust, much like Earth. Early Mars was not the cold desert we see today. In its infancy, it was geologically active. Volcanoes erupted across its surface. Lava flowed across vast plains. Gigantic volcanic systems developed, including Olympus Mons, the largest volcano in the entire solar system. Rising nearly 3 times higher than Mount Everest, Olympus Mons is a monument to the intense volcanic forces that once shaped Mars. But perhaps the most fascinating chapter of early Mars is the evidence suggesting it once had liquid water on its surface. Orbiters and rovers have revealed ancient river valleys carved into the landscape. They have photographed dried delta formations and sedimentary layers that could only have formed in the presence of flowing water. Mineral deposits discovered on Mars indicate long-term interaction with liquid water. Some scientists even propose that vast oceans may once have covered portions of the northern hemisphere. For liquid water to exist, Mars must have once had a thicker atmosphere, dense enough to trap heat and maintain pressure. Early in its history, Mars likely possessed such an atmosphere, composed primarily of carbon dioxide, with traces of water vapor and other gases released from volcanic activity. So what happened? Why did Mars transform from potentially wet and dynamic world into the cold, dry desert we see today? The answer may lie deep within its core. Unlike Earth, Mars is smaller and cooled more quickly. As it cooled, its internal dynamo, the mechanism that generates a global magnetic field, shut down. Without a strong magnetic field, Mars lost its shield against the solar wind, the constant stream of charged particles flowing outward from the sun. Over hundreds of millions of years, the solar wind gradually stripped away much of Mars' atmosphere. Without atmospheric pressure to sustain liquid water, surface water evaporated or froze. Some escaped into space. Some became trapped underground. Some remains today as ice at the poles and beneath the surface. As the atmosphere thinned, temperatures dropped dramatically. Mars became increasingly arid and cold. Today, the average surface temperature is around minus 60 degrees Celsius. Its atmosphere is less than 1% the density of Earth's. And yet, the scars of its past remain written across its surface. Valles Marineris, a canyon system stretching over 4,000 kilometers, dwarfs Earth's Grand Canyon. Impact craters preserve billions of years of history. Dust storms can engulf the entire planet. Polar ice caps grow and shrink with the seasons. Mars is, in many ways, a time capsule, a preserved record of early planetary evolution. Because it formed quickly and then cooled, Mars retains clues about the earliest era of the solar system, a time when planets were still assembling and conditions were violent and unstable. Studying Mars is like looking back into deep time, into the processes that shaped not only this planet but Earth itself. Meteorite analysis continues to refine our understanding of Mars' age and formation. Radiometric dating techniques show that Mars' core formed within roughly the first 10 million years of solar system history. Its crust solidified soon after. Compared to Earth's prolonged formation, Mars' rapid birth left it frozen in a more primitive state. Today, robotic missions continue to explore this ancient world. Rovers analyze rocks, drill into sediment, and search for organic molecules. Orbiters map mineral distributions and study atmospheric loss. Each mission adds detail to the story of how Mars was born and how it evolved. But the question of when Mars was born is inseparable from the question of what it might become. Because Mars formed in the same disk of material as Earth, it shares many similarities with our planet. A day on Mars lasts just over 24 hours. It has seasons, polar caps, and weather patterns. Its ancient rivers hint at the possibility that, at least briefly, it may have been habitable. Understanding its formation is not merely an academic exercise. It informs our search for life beyond Earth. It guides our exploration strategies. It shapes humanity's long-term dreams of becoming a multi-planet species. Mars began as dust in a collapsing cloud. It grew through violent collision and gravitational attraction. It differentiated into layers, erupted with volcanoes, hosted flowing water, and then slowly transformed into a frozen desert under relentless solar wind. It is a world that was born quickly, evolved dramatically, and now stands as both a relic of the past and a potential stepping stone to the future. When we look at Mars in the night sky, glowing faintly red, we are seeing the light reflected from a planet that has existed for nearly 4.6 billion years. A planet that witnessed the birth of Earth, the formation of oceans, the rise of life, the extinction of dinosaurs, and the emergence of humanity. Mars was born in fire and chaos. It matured in volcanic fury. It lost its atmosphere to the sun. And today it waits silent, cold, and ancient, holding within its rocks the memory of the solar system's earliest days. And perhaps one day it will witness something entirely new, the arrival of humans.